Question 5 then from paper 2 of the 2021 Higher Maths resource paper. It's the wave equation question. 6 marks here. The usual 2 parts. In the first part, you change this expression with 2 terms into an expression just with the 1 term, so that in the second part, you can simplify some expression to the degree that it can be solved. Well, usually that's disguised a little bit, but here it's just exactly the same in part B. So I've kept it very straightforward. So 4 marks first of all for expressing this in terms of a single sine with a phase. Not using phasors though, so you have to do it this way. You'll have to use the compound angle formula. Now you can set that down however you like. I'm just going to leave the k out of it just now and then just use the expansion of sine something plus something, which will be sine t cos A plus cos t sine A, and I should really put all these weird things back in again. I'm just doing it that way so I can now rearrange it to look like this. So t is the variable, A is not, A is this fixed value you're trying to find. So I'm going to keep that out, so k cos A, in fact I'll even put it in a bracket for emphasis, is the coefficient of sine t, and k sine A is the coefficient of cos t. Now, getting that line, either in 2 steps or in 1, is the first mark. Now you compare them. Compare the 2 expressions term by term. Right, the cos t should have a 3 in front of it, so that k, so that means that k sine A should equal 3. The sine term should have a 5, so that k cos A should equal 5. And I always prefer to put them down that way, or you should always prefer to put them that way, because then you've got the sine first and the cos second, because that makes a tan nicely. Right, so there's a pair of equations with 2 unknowns. So now you've got simultaneous equations. If you take equation 1 and equation 2 and square them and add them, you'll get the sine squared plus cos squared comes to 1, so that part will disappear. And you'll be left with k squared equals 3 squared plus 5 squared. You could probably just go straight in with this then. So that's going to be the square root of 25 and 9, 34. And it's going to be greater than 0, so it just is positive. So that's worth a mark. Next part would be, now if you take 1 and 2, but this time you do 1 divided by 2. The k's will cancel out when you divide the equations. You're left with sine over cos, which becomes a tan. So tan A is going to be 3 upon 5. Which means A is going to be, now there's 2 possibilities for this, but you've got simultaneous equations, so you have to make sure this is satisfied as well. So I'll just put a little diagram down just to show what's happening. All sine, tan, cos. Now, according to this, it says the sine, because k is positive, so it doesn't affect anything. The sine is positive, so it means you're either here or here. This one, because k is positive, says the cosine is also positive, so you're here or here. Well, there's only one quadrant that satisfies them, so it's in the first quadrant. So it's just a nice, clean, simple. It's the inverse tan of 3/5. Maybe I'll put that down first of all, but my next line I'm just going to leave the degree sign out of it because A is just a number. Missed a mark. There was 1 mark, of course, for getting the pair of simultaneous equations. Right, now just use your calculator. Then you just press the button and you get, and everything's completely accurate so far, 30.963 and so on. So I think I'll just go for, at this point, I've got more figures there in case I want them later. I'll just go for 31.0 for that mark. Although maybe that was a bit hasty. I don't think you get that mark until you've actually written it down here. Right, so the final answer is going to be, it's equal to root 34 sine t plus 31.0 degrees. I think the mark went there. Now, part B, just for the 2 marks. A function f is defined by this, which is just exactly what you had on this limited domain. Now, they've just limited the domain, so you don't keep putting the same answers down over and over again, because this obviously just repeats itself. It wants 2 things. It wants, first of all, what's the minimum value of this function? And then secondly, what's the value of t when this minimum occurs? So that's why it's got this limited domain, because otherwise I'd have to say something like the first positive value of t when it occurs. Well, the first thing you would do is you say, well, I can simplify that because I now know that that thing is equal to this. It's equal to root 34 sine t plus 31.0 degrees. And you know what that looks like. That's just your normal sine graph. That's been stretched up. So instead of going from 1 to -1, it goes from root 34 to negative root 34. And it's going back 31 degrees. But this says that you don't want this bit. So I'm going to have to finish that off to there, because it wants it to go from there to there. So it looks a wee bit like a cosine, except that's not its maximum. Well, that's the point you're looking for. The minimum value, well, you know what the minimum value is going to be. It goes up to root 34. This doesn't affect it at all. Well, it just affects where it happens. It goes up to root 34, down to root 34. So that means I can say straight away the minimum value is negative root 34. That's worth a mark. And it will happen when the sine's at its minimum. So it will happen when the sine is acting on, now that would normally be 270 degrees, so it will happen at t plus 31.0 equals 270, because that's the value of the angle that makes the sine come to -1. So that means that t equals, so you just take that across and subtract it, so that will be 239.0. I don't need to bother about any inaccuracies because 270 was exact. And that's the last mark, and that was number 2.